How a colorless gas reshaped the modern world. It had no smell, no color, no warning. And yet this invisible gas altered the course of industry, warfare, and daily life more than almost any invention before it. Most people think progress is driven by machines or ideas. But sometimes it comes from something far quieter. A gas so simple, it was once dismissed as unimportant. Today, its influence surrounds you, woven into energy, agriculture, medicine, and global politics. To understand why this gas matters now, we need to return to a time when air itself was still a mystery. Scientists knew it sustained life, but they did not understand its components. The atmosphere seemed uniform, passive, unchanged by human hands. That assumption would not survive chemistry. At first, isolating this gas felt like an academic exercise, a curiosity with little practical value. It reacted weakly. It did not burn. It did not explode. Compared to dramatic substances, it seemed boring. But chemistry rewards patience. One experiment revealed a strange behavior. Under the right conditions, this gas could bind, transform, and unlock reactions that were otherwise impossible. It acted not as fuel, but as a gatekeeper, allowing certain processes to occur while preventing others entirely. Slowly, chemists realized they were looking at more than a component of air. They had discovered a lever, a way to influence reactions on a massive scale. And once that realization took hold, the world began to change in ways no one could fully predict. As understanding deepened, the gas moved from curiosity to cornerstone. Chemists learned how to separate it, store it, and control its behavior. What once drifted freely in the atmosphere became something that could be captured and directed. This unlocked reactions that reshaped industry. Metals grew stronger and purer. Chemical processes ran cleaner and faster. Energy systems became more efficient. The gas did not provide power itself, but it decided which reactions could safely exist. It was chemistry's silent regulator. At first, the benefits seemed endless. Factories expanded, production accelerated, new materials entered daily life. Entire sectors reorganized around access to this invisible resource. Nations with control over it gained advantage without firing a single shot. But chemistry never operates in isolation. Introducing the gas at scale altered balances elsewhere. Reactions that once occurred naturally were suppressed. Others intensified. The atmosphere, once seen as stable, began to respond. What made this shift difficult to detect was subtlety. No explosions, no sudden disasters, just slow chemical drift. Emissions accumulated. Secondary reactions formed. The gas-enabled progress also changed how other substances behaved in air, water, and soil. This is where tension begins to rise. A tool designed to control chemistry was now influencing the planet's chemistry itself. The same precision that made the gas valuable made its unintended effects harder to reverse. Humanity had learned to command an invisible force, but it had not yet learned how to live with the consequences of commanding it. The conflict intensified as reliance turned into dependence. Entire systems were now calibrated around the presence of this gas. Remove it and production stalled. Increase it, and chemistry behaved unpredictably. Balance became a moving target. Scientists began noticing feedback loops forming beyond factory walls. Atmospheric reactions shifted. Protective layers thinned. Reactive species traveled farther and lasted longer. What had once been contained inside controlled environments now influenced global chemistry. The most unsettling discovery was timing. The gas did not cause immediate harm. Its effects accumulated slowly, almost invisibly. Year after year, small chemical shifts compounded into measurable change. By the time patterns became undeniable, the gas was deeply embedded in modern life. Attempts to reduce its impact exposed another paradox. The same gas essential for progress had become essential for protection. Removing it too quickly created new risks. Replacing it required reactions that introduced different uncertainties. Chemistry offered no clean exit. This was the emotional buildup, a realization spreading through scientific communities and policy circles alike. The modern world had been built on an invisible foundation, and that foundation was no longer stable. The conflict was no longer about discovery. It was about restraint, about learning when to stop pushing chemistry forward and when to let natural systems recover. But stepping back proved far harder than stepping forward. The gas had done exactly what chemistry allowed it to do. It was human ambition that had multiplied its reach beyond control. The climax arrived not with catastrophe, but with clarity, the understanding that an invisible gas had quietly rewritten the rules of modern life. It was never evil, never reckless. It followed chemistry perfectly. Under pressure, it reacted. Given opportunity, it expanded its influence. The real shock was realizing how deeply everything depended on it. Industry, medicine, food systems, and global safety were all tied to a molecule most people never think about. This was a turning point. Scientists, engineers, and governments began to see the same pattern repeating. Control without boundaries. Innovation without long-term vision. Chemistry moving faster than wisdom. The gas had not failed humanity. Humanity had failed to anticipate scale. The resolution is still unfolding. New reactions are being designed. Alternatives tested. Systems rebalanced slowly and carefully. Not to erase the gas from history, but to limit its reach. To learn how to work with chemistry instead of overpowering it. This story reveals something essential about the modern world. Progress is no longer loud or visible. It is quiet, molecular, invisible, and once it reshapes reality, reversing it is never simple. Understanding chemistry means understanding responsibility. Every reaction leaves a footprint. Every molecule carries consequence. And the future depends on how carefully we choose which reactions to allow to grow. Subscribe to join the journey.